In this video, we are going to discuss what steps you should follow and think carefully about to make sure the experiment you design is conclusive. Here are the steps. We are going to cover them in detail, but first I want to give you an overview. First, we have to define a treatment variable, X. What are we going to vary across groups in an A/B testing? Then choose a test setting. Where are we going to run this experiment? Choose a response measure. Are we going to look at number of clicks, for instance, for an ad, or number of sales? Select the unit of analysis. Are we talking about people, stores? Select the subjects, and then sample within these subjects to assign them to various treatment units. So in an A/B testing, it will be group A and group B, for instance. Let's discuss how to define the treatment. Defining the treatment consists in picking X and its possible values or categories you want to use in your experiment. You might look at the business question and then what hypothesis you need to test to answer it. From there, you might have a good idea of what would be the treatment, but not always. For instance, if you're trying to decide if you should hold events for alumni, ideally you would want X to be whether you hold an event or not. But in that case, not holding an event might make you lose a lot of money in donations. So maybe you can instead choose whether you invite someone or not to the event. That is a very different treatment. Is it easier to test? Certainly. Will it help clearly answering the business question? It's not so clear. So you might look for better approaches. For each treatment, you need to assess the potential costs and benefits. If you're testing a discount, you might ask how much it would cost if people use a discount but sales don't increase. So in that case, only people who would have bought the product anyway are purchasing, but we get less revenue for each sale. At what point does it become profitable? Do we need a 5% increase in sale, a 10% more? So make sure you're aware of the potential costs and benefits and that it looks like it's actually worth running the experiment. Finally, let's talk about control groups. You might have a specific treatment in mind, like offering a discount, for instance. That's your group A. What is group B in your A/B test? What do you compare group A to? Business as usual? It might be, for instance, spending marketing budget on advertising instead. Or no action, so no discount for group B, no advertising either, just nothing. You might look at a placebo, for instance, increase the price and then pretend to discount your product by showing the original price as a discount. Be careful, while this is common on some online platforms, it might be illegal in several places. Finally, you have positive control, which is when you have a treatment that you know produces the desired effect and you want to compare another treatment. For instance, you might already know that when you offer a gift with each purchase, you tend to sell better. So you might use that in the control group. Then you have to choose a test setting. This is where the experiment is going to happen. It will, of course, depend on the treatment you choose. It could be online, a physical flyer, an email to all your customers of 3 randomly chosen states, or physical stores. One place where the experiments are often run is the lab. It doesn't have to be a medical lab, it could be a behavioral lab where you can get people to taste products, or where you have a fake store in a studio with a lot of cameras to follow people's behavior. So the lab is great because it allows you to control for external factors. You know who is entering the lab and what they are doing with accuracy. And you might be able to test for things that you might not be able to test in a real setting. However, it might limit the external validity, and results you get in a lab might not be well reproduced in the field. So instead, you might consider a field experiment. That means a real-life setting, an online platform, a physical store, a flyer you actually distribute to customers. This is good for external validity, but might be more risky and more costly. What if the experiment fails and your revenue collapses? What if it requires you to completely change the layout of a bunch of stores? It might also be harder to measure results or other control variables relatively to a lab, like demographics, if people were previous customers. You have to think about all of these factors. There are cases where you can do something in between. If you have many stores, for instance, you might want to run the experiment first in only one store, where you also ask people to fill a survey to have additional information while you try various treatments. This will allow you to still control for some external factors, while you have a better external validity because it's still in the field. So it's a bit better than the pure lab setting in terms of external validity. Then you have to pick a response measure. This is a Y variable. Good measures are related to business goals, so they help answer your business question, and they should be affected by your treatment. Things to consider are the distance from the treatment. For instance, if you run an ad, the first thing people do after seeing the ad might be to click on the ad or not click on the ad. So the measure of click is very close to the treatment. Or they might come and visit some pages, so that's one step further, or maybe come the next week and buy something. So this purchase decision might be very far from the treatment. It happens after several steps. Usually measures that are close to the treatment have a stronger effect, easier to measure, but they might be further from your business goals. So you have to consider that. You might also consider to take multiple measures, so both the click-through rate for an ad and the number of purchases within a week. The problem then is which of these measures do you actually pick to make your decision? It's not really clear. Finally, the time span of the measurement. Maybe if you run some ad, your brand awareness will increase, and you might have an effect that's 2 months down the line. It's a long time to wait to have the result of an experiment. Maybe instead you want to see how many people come to the website 1 hour after you start an ad campaign, for instance. So you have to consider that too. Then you have to pick the unit of analysis. For instance, if you run a digital ad campaign, you might want to know if a person sees the ad, if they are going to purchase a product or not. But you might not know who has seen the ad. Maybe you know if a household has seen the ad. For instance, you play ad on their TV on Netflix, and you might know that someone purchased the product, but you are not sure who has seen the ad. You just know the household has seen the ad. Or maybe you just know a computer has been exposed to the ad. So you have to consider which of these units is best, which one you can observe, and which one would answer your business question. Other examples include looking at stores versus salesperson, or days versus hours, or different time units. Geographic area, are you looking at a district, a city, a state? The market, which product, keyword, segment, especially in advertising, this is important. Or a combination of those, so you can combine user and days. Ideally, you want a small unit that you can observe with independent response. For instance, if you apply a treatment to a whole store, the salesperson performance might not be independent because they are all working in the same store. So in that case, you would pick the store level. So think about the independence of the unit and if you can observe them. Now that you have picked the unit of analysis, you might think about selecting subjects. How are you going to recruit your subjects? It might be a bit difficult, especially with people. Suppose you are doing an A/B test on advertising for your student organization with students at the business school. What would be the best way to choose the subjects? Maybe you're thinking about setting up a table in the lobby and ask students who walk to participate. Reward the one who participates with a free pen. So, is this a good sample? Is it representative of the population that is targeted? Maybe only students that are interested will participate to this event. Maybe instead you want to ask the administration to provide a list of all students and send all of them an email invitation. Maybe that's better, but it might be also more difficult. You can take a random sample of 400 students and send them a personal email inviting them to participate. And then if they don't participate, maybe you want to follow up for the people who didn't participate with a second email. If they still don't answer, maybe you want to get their phone number and call them. If they still don't answer, maybe you have to find their schedule and visit them in class, and then you get arrested for harassment or stalking. So a lot of considerations here that might not be the best option. Maybe you want to select 6 cohorts at random, visit each cohort during their core business analytics class, and run the experiment. This might be a good option because these students will understand what an experiment is, but maybe they are not your target population. So think about all of these when you are selecting your subjects. So now you know how you're going to recruit people, you know what treatments are going to be applied, you have to think about the sampling strategy, so knowing which unit is going to receive which treatment. There are many threats to external validity you have to deal with when you are thinking about the sampling strategy, because you might get a sample that doesn't represent the target population well. Some strategies include, from ideal to worst, the simple random sample. So you look at the people you have and you randomly select n subjects from the target population. If you have an A/B test, you might think you are going to give the treatment 50% and the other treatment to 50% of the other subjects. But if you have cost consideration, the treatment is very expensive, maybe you want to pick only 10% of the people to apply the expensive treatment. Or if the treatment is risky too. So if you risk losing sales by applying the treatment, maybe you don't want to have a large share of the sample that is randomly selected to receive the treatment. Another approach is the cluster sample. That's when you have similar groups that are called clusters, and they are relatively homogeneous, they are relatively similar. For instance, the 5 sections of the class. You randomly pick a few of them and you apply one treatment to these randomly selected groups and the other treatment to the other clusters. When you have different groups but they are not identical, they are not similar, for instance, in-state and out-of-state students, then you can sample randomly within each group. So you take a group of in-state students and you randomly split them. And then you take a group of out-of-state students and you randomly split them and apply the different treatments. Finally, there is a convenient sample, which is sampling in whatever way is easy for you to do. Like you have a survey, you go to your friends and your neighbors and you test the survey. This is often done to pre-test a treatment. So before we spend a lot of money sending a mass mail, maybe you want to have feedback from people you know. This is also very useful for consulting proposals. So you don't necessarily have the consulting contract yet. You don't want to spend a lot of money, but you want to show some data and say, I've run an experiment. It was a convenient sample. These are the results. So we are confident that we can run the experiment to a more representative sample. So now you're ready to run the experiment. It's all set up. You know the outcome you want to measure, you know how you get your sample, how you randomly split it, you know what treatment you apply, you know where you apply it. So you run your experiment and you get your results. What to do next? Well, you already know the methods you need to analyze the result. You can use hypothesis testing methods, regression, time series analysis, whatever is the best fit to get the answer you need to make your business decision. The big difference when you apply these methods to an experiment is that if it's well designed, you can make a causal claim. So you can say an increase in price by $1 causes the sale to collapse by 2%, instead of just saying it's associated with a collapse in sale.